All right, welcome to today's Explainer. If you follow the tech world, you already know that quantum computing is a field that's, well, often drenched in extreme hype. But a recent article in Science magazine covers a massive, deeply controversial announcement from Microsoft, and it's got the entire physics community talking, debating, and honestly, outright arguing. Three years. That is the literally audacious timeline Microsoft just announced for building a practical, useful quantum computer. To put that frankly shocking number into perspective, a lot of experts in this field firmly believed we were still decades away from anything resembling a truly useful, scalable machine. Okay, let's dive into this. Here is our roadmap to unpack both the complex science and the heated academic drama. We'll be looking at 1. The 3-year promise. 2. The quantum noise problem. 3. Microsoft's topological qubit. 4. Why critics are scoffing. And finally, 5. The 2029 Judgment Day. Section 1. The 3-year promise. Accelerating the timeline. Chetan Nayak, the physicist who leads Microsoft's quantum computing effort, recently made a stunning declaration. The tech giant has officially slashed their target for a scalable quantum machine from the year 2033 right down to 2029. Section 2. The quantum noise problem. The enemy of progress. To really grasp why a 3-year timeline is so wild, we first need to understand the fundamental hurdle the entire field is trying to jump over. Now, you might be wondering, what's the big deal? Well, the contrast between classical and quantum computing is stark. A conventional computer uses everyday bits. They are strictly limited to being a 0 or a 1. But a quantum computer manipulates qubits, which can be 0 and 1 simultaneously. Because of these incredibly unique wave-like superposition states, a quantum computer can analyze many inputs at once. It's kind of like ripples in a pond. The quantum states interfere with each other to cancel out the wrong solutions, making the right one just pop out. When it works, it is an absolute game changer. But there's a massive catch. Environmental noise easily fuzzes out these delicate quantum states. You can build qubits out of tiny superconducting circuits, lone ions, or single photons, but the moment they interact with the outside world, like a tiny temperature fluctuation or a stray electromagnetic field, that magical superposition just instantly collapses. This noise problem is exactly why today's quantum computers are stuck at just a few hundred qubits. Section 3. Microsoft's topological qubit, a Byzantine design. So, how do we fix this? Well, Microsoft's proposed solution is a microscopic device called a topological qubit, designed to be far more robust against this noise. Let's walk through the physical construction of Microsoft's proposed chip step by step. Step 1, they lay down semiconducting layers to form the base. Step 2, they add a strip of superconducting metal on top, which induces a wire-like region of superconductivity right underneath. Finally, step 3, a tiny electrode called a quantum dot injects an additional unpaired electron into this wire. So the wire either has an even number of electrons, representing a solid 0 state, or an odd number, representing a clear 1 state. The core science here is all about what are called Majorana zero modes. Essentially, that lone unpaired extra electron becomes delocalized. It exists everywhere along the wire at once. Because it's physically spread out like that, it is incredibly hard for localized environmental noise to disturb it. Its unusual topological shape physically protects the state from the outside world. And this brilliantly illustrates the massive leap in stability they claim to have achieved. Back in February 2025, using an aluminum superconducting strip, the qubit state lasted for about 2 milliseconds. But by swapping that aluminum out for lead, today they claim their lead qubit lasts an astonishing 20 seconds. According to Microsoft, that massive 20-second leap is exactly what puts a full-fledged quantum computer within a 3-year reach. Section 4. Why critics are scoffing. The academic feud. Because despite this massive stability claim, you need to know that the broader scientific community is incredibly skeptical. Microsoft admits they've been a bit cagey in the past. Chetan Nayak recently defended their approach, stating, "We said just trust us, we're going to make the topological phase more robust. Now we're revealing more." They now claim to have unpublished data showing they can fully control these qubits. But yeah, that just trust us approach, it is absolutely not flying with the wider academic community. Sergey Frolov from the University of Pittsburgh points out, the Microsoft Quantum project follows a sustained pattern of unreliable claims. You go to a conference and somebody mentions Microsoft and people are chuckling. He points out that a 3-year timeline seems highly implausible without a running lab prototype right now. Furthermore, physicist Henry Legg from the University of St. Andrews argues that Microsoft hasn't actually tuned into their rare Majorana state at all. He suggests they merely found a quiet spot in a landscape of noise. Let's systematically break down these critics' alternative theories. First, Legg argues that the electron might just be hopping on and off an incidental quantum dot, meaning it's just a standard artifact, not a magical state. Second, critics point out there's zero published evidence the device works as an actual qubit. Microsoft hasn't proved they can ease the device into different controlled states. And finally, just because the state physically endures for 20 seconds does not automatically mean a delicate quantum superposition will maintain itself for that long. Section 5, the 2029 Judgment Day, Revolution or Joke? So what does this all mean? We are looking at incredibly high stakes here as the clock ticks down to Microsoft's self-imposed deadline. Henry Legg's final assessment is, honestly, biting. He says, at this point, I think that this is less the realm of reality and headed to something more like a quasi-religion. The clear implication here is that Microsoft researchers might have simply convinced themselves of conclusions their own data does not yet support. So, I leave you with this final thought. Will 2029 bring a quantum revolution that changes computing forever, or is it just another broken promise in a hyped-drenched field? Whatever happens, Microsoft has backed themselves into a very tight 3-year corner, and the entire scientific world is watching. Thank you for joining me for this explainer, and definitely keep a close eye on this space over the next 3 years as the truth unfolds.